All right, so for the first question in exam 3, we needed to match these 8 equations with 8 different graphs. And so one of the first things that we can do is kind of divide the graphs into 2 types. We've got ones that are continuous and we've got ones that are not. So based on what we've talked about this week, we have 2 styles. One, we have the polynomials, those are continuous, and then the other are the rational, that they're going to have points of discontinuity. So we can kind of break those pieces up. If it's got a fraction bar, right, then we're rational, and otherwise we have the polynomial style. So there are a few different things that we can look for. First off, we notice that well, if we're just looking at these and we can get a sense of what they're like. If we look at 4, 4 has the second degree to a first degree. Now it's the only one, if we notice, whose numerator has a higher degree than the denominator. So that one's going to look a little different, and we know that that should have a slant asymptote. So we're going to be able to see that we have that slant asymptote here and going down here. So that one's pretty obvious. We only have one whose denominator is larger than the numerator. So that, since the denominator is growing faster, that means that we're going to be approaching 0 as our x's get large, either in the negative or the positive realm. Okay. And we see that. So we've come up with 2 of them so far. We have this one, we have this one. Then we can look at a few others. If we didn't know anything else, we could look at, for example, if we look at f sub 1 and f sub 6, they're the exact same thing, only one is multiplied by a negative 1. So that's going to be a vertical reflection from the other. So one's going to be a vertical reflection of the other. And notice each, they're in factored form. So these have zeros at -2 and +2. And they both have a multiplicity of 2. So if we look locally, it's going to look like we have a parabola at those local spots. So if we have this one, and we also have this. So those 2 pairs give us those pieces. So we've just got a couple more left. We've got f2 that we haven't dealt with. We've got f5. Oh, and let's look at 5 and 8. 5 and 8 look very similar, except the multiplicity of 2 is on the x equals -2 root for 5, and then for 8, the multiplicity of 2 is on the root of 1. So when we have a multiplicity of 1, we know that we're going through that 0, kind of approximating a line. When we have a multiplicity of 2, we hit the 0 in something that locally looks like a parabola. So here our parabola, our local parabola is going to look at -2 and then through a line at 1. And then if we look at this one, we'll have the reverse situation. We're going to have a line going through the -2 spot, and we're going to have the parabola part on that. Okay. And we've covered almost everything. It looks like 7 and 2 are our other options. The only thing that's different between 7 and 2 is that this is being multiplied by 2. Notice everything else is the same. We've just multiplied by 2. So whatever we have here, we should have everything stretched out by 2 here. And notice what that does is makes the horizontal asymptote at y equals 2 instead of at y equals 1. Okay. And I think that covers all of our different graphs. And that should get us through problem 1.